This is a double-acting slide valve model of a mill steam engine, and it's a commercial kit of materials, drawings, and an instruction manual which is quaintly worded. It's a little difficult to interpret, and a lot of the methods I had to modify because, quite honestly, you see that inlet valve or the inlet fitting, and on the other side the exhaust. They recommended doing this with special model pipe threads, which just the dye and the tap alone would have cost $70. So I made my own using ordinary the threads that I already had taps to. Well, they need now little gaskets, but what the hell, that works very well now. I had to modify a lot of stuff here because it was very difficult. See that little fitting there that they said bend? Well, I looked at it and they didn't talk about annealing it or softening the brass, and I broke two before I said I'm going to do it my way. So that's what I did, and I had to modify a few things. They wanted to suggest machining the crank and the crankshaft out of a solid billet of steel. Well, I thought I'm not going to do that, so I pressed in the shaft, and much easier and a few less steel chips in my little workroom. But and I machined with a fly cutter the external, or the billets that I made them from, so that they are nice smooth surfaces. You can see that little steam chest, and on top is the cover, and underneath it in the brass is the valve plate, and there are no gaskets. They have to fit very closely without leaking, and I think machining a really flat, clean surface is the only way to go. The instruction booklet didn't suggest anything like that, so I guess I did it the way I thought it would. But now it's come together as a very nice little engine. That's the reversing valve. It has to be adjusted rather carefully, but everything works, and you'll see it running later on in this video. But it's pretty, and it actually runs very nicely. So there it is. It's a nice little engine. It finished up, but it took a lot of modifications to get it just right. Extra parts that I didn't use, and that's the engine, and it runs very nicely. So you may be able to hear it popping over as I give it a spin. What it's doing actually is just pumping air through. Well, there we are. Little slide valve, which is very slim. It goes all the way through to the end here, and it's got a tiny little thread in the middle, and of course it has to be machined exactly concentric. Well, they said to do this without any, well, you can't do it. So I had to do it in centres, which is not in the manual, but anyway, I finally got it together, and as you can see from it runs very well. It's very free, and well, it's a nice little engine when you finish, but oh, goodness help me, I had to make several parts over again, and again I didn't do, they say machine this crank and shaft out of one solid piece. Oh, nonsense. I did it as a separate bit and pressed in the shaft. So anyway, that's the way the action. It's an interesting valve gear. There we are. nice little engine, but a bit of a problem to put together the way they wanted it. So, like everybody else, I think I can do better, so I did it better, and there it is. This is the little mill engine running in one direction. It will run on a very low air pressure, and of course if you speed it up it really whizzes. I'll see if I can get a different viewpoint. And this is the engine running in the opposite direction. The reverse lever doesn't seem to have any throttling effect, and it has to be fairly carefully adjusted in both directions. The valve mechanism is so finely, it's a tiny little thing, and it's to very small tolerances. As you can see, it's let's see if I can come in just a little closer. You can see it there. Well, actually it's slowing down now because my air pressure is running down. I'll have a look and just see when it stops, just see how low the pressure has gone. Still running, still running. Finally stopped at about £8 per square inch. My goodness.